So, what is a graph? One way to represent a graph is through circles connected by lines. We call these circles vertices. And the lines connecting these circles, we call them edges. This graph in particular has 4 vertices and 4 edges. As you can see, 1, 2, 3, 4. 1, 2, 3, 4. Another example of a graph is the following. This graph has 1, 2, 3, 4, 5, 6, 7, not 8 vertices, and we have 1, 2, 3, 4, 5, 6 edges. Some number of vertices, heck, it could be a million of these, but there are no edges. This is what we call null graph. Alright, well, enough jokes. Time for a formal definition of a graph. Yup. So, a simple graph G, say with n vertices and m edges, consists of 2 things mainly. Consists of a vertex set, we write as V for vertex, of G, specifying which graph, as the set of vertices, in this case, from V sub 1 up to V sub n. Here n because we stated with n vertices. And also an edge set, which we write as E of G, as the set of, man, what's going on with my brackets? E sub 1 up to E sub m, where each edge is an unordered pair of vertices. When we say unordered, is that if we have an edge with vertices, let's say V sub 1, V sub 6, then this edge consists of vertices V sub 1 and V sub 6, and vice versa. V sub 6 and V sub 1. That was fun. Now, formally, we write UV for the edge with vertices UV. Okay? If the edge UV is in the edge set of G, then U and V are adjacent. And this idea of adjacency is important. Okay? Now, the vertices contained, contained in an edge E, okay, so some edge named or labeled E, are its endpoints. So if we had an edge E, these vertices were to be A and B, we say that A and B are the endpoints of E. Now recall that I said simple graph. What that really means is, oh boy, what that really means is that we have graphs which only have one edge between vertices. We do not consider or take into account graphs with multi-edges. So that is, we don't take into account graphs that have more than one edge between vertices. Okay? Unacceptable. And also, simple graphs don't have loops. This one doesn't have loops. Now this one right here, we do not allow edges going from one vertex all the way back to the same one. Okay? So this is not going to happen. Exercises. So consider the following graph G. This is going to be V1, V2, V3, and V4. Okay? The vertex set of G is defined as vertex V sub 1, V sub 2, V sub 3, and V sub 4. And the edge set of G here would be defined as, notice how v sub 1 and v sub 2 are adjacent. So v sub 1, v sub 2 is an edge. Observe v sub 2, v sub 3 are adjacent. So v sub 2, v sub 3 is also an edge. You can also see that v sub 2 and v sub 4 are an edge. And v sub 1, v sub 4 is also an edge. Okay? So here the size of the vertex set equals 4. So we say G is of size 4. And the edge set has size 1, 2, 3, 4. 4 as well. So we say that G is of order 4. Great. Now consider this crazier graph. Say H. This is going to be vertex A, vertex B, C, D, E, F. The vertex set of H equals vertex A, B, C, D, E, F. And the edge set, well, I'm going to let you look at it for a minute. Well, now you've been looking at it, you can see that AB is an edge, BC is an edge, BD is an edge, BE, FE, not so hard, right? In total, we have that the size of the vertex set of H equals 1, 2, 3, 4, 5, 6. The edge set of H has a order of 6 as well. Well, for examples for next time. But you get the idea. Anyways, let's break it there. Thanks for watching.